I love this problem. It's got a little bit of everything in it. All right. So here we go. It's got a propeller of a World War II fighter plane. It's 2.1 meters in diameter. Got to be careful with that D word, diameter. Okay. What is the angular speed in radians per second if it's at 1,220 revolutions per minute? I'm going to tell you right now. On your exam, you're going to do a problem just like this. Right here. This type of thing. We're going to convert revolutions per minute into angular velocity, or they should actually say angular speed because it doesn't have a direction, right? The direction of it depends on which way the propeller is going, turning, all right? And I'll show you what I mean. The direction, so let's say the propeller is going this way. All right, so let me draw my propeller here. All right, so here's my propeller, and let's say it's going this way, around this circle like this. So that would mean that its thrust is going up. Actually, the propeller would probably be going this, if the airplane is back here. In other words, here's the front of the airplane. Here's the two tires down here. If the airplane is, the propeller would be going this way. Why? Because it would be pushing air back. Then the air from it would be pushing the air back, which for every action there's a reaction in the opposite direction of the same magnitude, which would then the air, all these air molecules back behind it would push it forward. We'll get into that later. It didn't, but I think it should have just said speed. Okay, so it's got an angular speed, omega, is equal to 1,220 revolutions per minute. How do I get that into radians per second, which is also an angular speed? Notice, all I got to do now is, I need to get rid of my minute. So 1 minute is 60 seconds. And 2 pi is 1 radian. Is 1 revolution. It's not 2 pi is not 1 radian. Okay. So I take 1220 times 2 pi divided by 60 seconds. A lot of stuff here would cancel. And in fact, I think I told you that if you take 1220, if you take anything times pi over 30, in fact, let's just put pi over 30 into our calculator, and we could even store that. Second pi divided by 30, and we're going to get a number of about 0.1. I'm going to get out of Scientific American, or scientific notation. There we go. 0.147 is my constant for pi over 30 times 1220. Equals 127.76. Notice what I'm doing. With good old expert ta, I'm taking it out to, let's go ahead and go 0.758. This is my angular speed of 127.758 radians per second. Now, I'm sure we're not stopping there. What else do they want? They want, what is the linear speed in meters per second at the tip of the plane? All right, so we just did this problem. We just did this in the last one. We know the angular speed. We know the radius. Let's go back and let's find the radius real quick. What did they tell me the diameter of this sucker was? Sorry. 2.1 meters. So R is equal to 2.1 meters. No. R is equal to 2.1 meters divided by 2, which would be 1.05 meters. I don't need, And what did we learn? The tangential speed, linear means tangential. It depends on which physics text you're reading, which physics professor you have. So the linear speed, V, is equal to R times omega. So you get 1.05 times 127.758. So once again, this is meters going into radians per second. This is a unitless thing, so I've got meters per second. It's going to be close to the same thing, 134.15 meters per second. And the last thing they asked me, what's the centripetal velocity? What's the centripetal acceleration? In other words, what's the force going this way? Okay? What's the force being caused? So in other words, those particles here at the tip of this blade, they want to go flying off this way. They want to go flying up. Well, we already said it's probably going this way. So they want to go straight, but they're being kept in place by their chemical bonds and stuff in here, and those chemicals are exerting that centripetal force. It's going that way. Okay? And so that centripetal force is equal to v squared. Centripetal acceleration is equal to v squared over r. The force, the centripetal force, is equal to the mass times AC, but they didn't tell us the mass at the tip of that propeller. So we've got 134.15 squared divided by 1.05 meters. That's a little bit longer problem. Oh, sorry. So one of the nice things I do with my cat is I just keep the calculations going all the way through. So squared, that answer, divided by 1.05. Whoa! 17,138. We'll leave it that way. 17,138 meters per second squared. How many G's is that? Well, you divide that by 9.8 meters per second per G. So the number of G's, just divide that by 9.8. And I've got 1748 G's it's pulling there. So there's A, B, C, and D. I don't even know if, oh, did they ask that question? Let me see. I'm looking at my answer sheet so I don't get too bogged down. Well, let's just go through. Let's just make sure we got all this. I'm confident. See, I wish they'd have given this as an omega. That's probably confusing to those of you that are new that this is a V. That's a V there. I don't like it. I shouldn't say that because then you'll all will get discouraged with it. They're good questions. They really are. They're just now here's the tangential speed, which I got as 134.15 meters per second. Submit that. Yeah, correct that boy. I'm on a roll. Okay. I don't know why they give it to me. So why I had to do it in G's, but I read something 117, and just so I don't get confused, comma 138. Yeah, we flew through that, didn't we? That's kind of a long problem, so maybe we should record that and go on to the next one.